All right, we talked about parallelograms before, and let's just talk about it again. We're going to talk a lot about it. This whole lesson is talking about parallelograms, but you're getting really specific. So really, what's the only thing? And I'll tell you what. Let's make this look like one of those parallelograms. Okay, there we go. So that looks like a parallelogram. What do we know so far? Let's everybody listen. Shh, guys, stop the conversations and look up here and pay attention. So what do we know so far about the parallelograms? Mario, what'd you say? Two pairs, not congruent. No, not equal. Parallel, thank you. So, look, these two sides. Now, what you said, Mario, what you said is not incorrect. But we haven't learned that yet. We're going to learn that in this period right now, okay? So, you are right, but it's not really what I asked. What do we know so far about parallelograms? We know we got two pairs of what? Parallel sides. We didn't say anything about them being equal to each other, have we? We've never said that. We're going to say it today, all right, a little bit later, all right? But this is what we know by so far. And we know that's true by what? By definition, all right? So if I asked you, why are these parallel and why are these parallel? You would tell me they're parallel because that's the definition of a what? Parallelogram. Exactly. Everybody, you got that? What we're going to do today are all theorems. Okay? They are called theorems, which can be proven. We're not going to prove them all. We might talk a little bit about a couple of them, but that's what we know so far. It's really the only thing that we know so far about parallelograms. Now, we do know some special types of parallelograms. What are some special types of parallelograms? Well, quadrilateral is not always a parallelogram, so you can't say that. A rhombus is a special parallelogram. A square is a special parallelogram. A trapezoid is not a parallelogram. Okay, a kite is not a parallelogram. I want to know what are parallelograms. What are some special ones? Rhombus, square, and rectangle. You got it. Okay? A trapezoid only has one pair of parallel sides. A parallel's got to have two pairs of parallel sides. Okay? A kite doesn't have any parallel sides at all. You hear that? So a kite isn't even close to a parallelogram. Would you agree? All right. So it is a polygon. That's true. All these things are polygons. So let's continue. Let me grab this and copy it so I can have to redraw it every time. All right. So what we're going to do is we're going to learn some special things. Okay, stuff that we really didn't know before, we're going to learn today. These are theorems. So I'm going to give you two theorems that I was going to say similar, but they're not really similar to each other, but they kind of have a little bit to do with each other. All right, so two theorems. I'll put a little star, a little asterisk right there, a little star showing both of these. So here's what the first one says. It says that the consecutive angles, we've learned that word before, right? Consecutive. We've talked about consecutive angles. So the consecutive angles of, if I could write here, of a parallelogram. I don't know if I showed you this before, but that's your little symbol for parallelogram. Kind of looks like a parallelogram, doesn't it? Kind of. I didn't draw that perfectly, but that's okay. So consecutive angles of a parallelogram are supplementary. They're not equal, they are supplementary. So I'm going to look at that here in a second. We've used that word supplementary. That's not a new word. What does that mean when you hear the supplementary? What do? They add up to 180. Very good. Okay, I'm going to write that down so we remember. They add up to 180 degrees. So let's call this ABCD. Let's find which angles, first of all, are consecutive angles. Remember that word? We've used it recently. We used it a while back. Do you remember when we had parallel lines cut by a transversal? Remember that? We had consecutive interior angles. We got that here too. Look, I got parallel lines, don't I? Okay? This would be considered a transversal. So would this one right here. And so when we have parallel lines cut by transversal, what do I know about the consecutive interior angles? They're not equal, they're what? They're supplementary, which means they do what? Add up to 180. So angle A plus angle D is going to equal what? 180 degrees. Okay? You with me? That also means that angle B and angle C are going to equal 180. But we're going to get to that in a second. So that's the first theorem that we're going to talk about. We're going to come back to that in just a second. Let's do a second one. This is another theorem, and this theorem says that the opposite angles, not consecutive this time, but the opposite angles are of a parallelogram. I should put that on there. Of a parallelogram are, now let's just take a look at it and just make a wild guess. Look at angle D and angle B. What do they look like they could be? Oh, well, they're opposite. We know they're opposite, but congruent. It looks like they're equal. It looks like they're the same, doesn't it? See that angle right there and this angle right there? They look like they are equal to each other, right? The measures are equal, or they're congruent to each other. And it's absolutely true that they are, because that's what this theorem says. It says that the opposite angles of a parallelogram are equal. You could say congruent as well. It's fine. All right? So if this one, if the angle D has two arcs, what am I going to do with angle B? What? They're equal to each other, so they have the same number of arcs. So angle A's got one arc. What's angle C going to have? One arc. Everybody with me? So look, the opposite angles are equal to each other. Make sense? Yeah. And so now we know that. You might have been able to guess that before, but now we absolutely know that they're equal. Now look at the rest of the consecutive angles. So we said A and D add up to 180. What must be true about A and B? They add up to 180. What about B and C? They add up to 180. And then D and C, they add up to 180. Or they are what? Give me one good geometry word. It's on there. It's right up there on the screen. They're supplementary. Very good. Okay, if they add up to 180, it means they are what? Supplementary. All right? And the opposite angles are equal. So you know what they're going to do on a homework, right? They could tell you, I don't know, what does angle A look like it is? Maybe like 120 degrees, maybe, something like that. Okay, so what if angle A is 120 degrees? I should be able to find all the other angles just knowing that one angle. So if that's 120, what's the easiest angle to find? C. Why C? Because they're equal, that's right. So if this is 120, what's angle C? That's also 120. But if this is 120, what's angle D? How'd you get that? You got it. 180 minus 120. Okay, which is 60. So that's got to be what? That's got to be 60. So angle B's got to be 60 as well, right? For a couple reasons. Actually, 3 reasons. Look, it's equal to this one. That's one reason. It's supplementary to that one, right? So 180 minus 120 is still 60. And it's supplementary to this one. 180 minus 120 is 60. You see that? So just knowing one angle, I should be able to figure out what all the other angles are. We good with that? All right. Let's change pace a little bit and go to the sides. Well, actually, no, we got one more thing to do. I was jumping ahead a little bit. Let's do this one. All right, here's another theorem. Oops. Yeah. There we go. So this is another theorem, and it says this. Let's write it down. It says, if a parallelogram, so instead of writing parallelogram, I can just write that little picture. Is that all right? Has one right angle, then that parallelogram, or I'll just say it, is a rectangle. Aubrey, you writing this down? I see you doodling. You should be writing this down. Square is always a rectangle. Because what's a rectangle? A rectangle is a quadrilateral with 4 right angles. Okay? Does a square have 4 right angles? Yep. So every square is a rectangle. But is every rectangle a square, though? No. All right? That's another story. Let's take a look at this. This says what? If a parallelogram has what? 1 right angle. So I don't care where you put it. Let's just put it up here. It says if it only has 1 right angle. I tell you what, before I do that, this picture right here, can you say 100% that that's a rectangle? No. Why not? That's right. 'Cause, well, you don't see any angles, right? You don't know what these angles are. It looks like a right angle, but can we always go by that? Nah, because it could be like 89.999 degrees. Is that a right angle? Technically, no. It's pretty close, but it's not a right angle. But they do tell you this is a parallelogram, though. Okay, they tell you if it's a parallelogram. You got it? So if it's a parallelogram, and what else do we know about this? It's got just one right angle. So that's the only thing they tell you. It's a parallelogram, and there's one right angle. Remember, it's a parallelogram. So if this, we'll call this W, X, Y, Z. So if this is a right angle, can you find the other angles like we did earlier? Okay, what's the easiest one to find? The Y. What is that? It's a right angle. Why? Because if that's 90, opposite angles, no, opposite angles. Opposite angles are what? Equal to each other, okay? So the reason why angle Y is also 90 degrees is because of that theorem that we just talked about, right? That said that opposite angles are equal. Now, what about angle Z? Why is it 90? Because it's supplementary, right? It's 90 for a different reason than this is 90. You got it? This is a right angle because it's supplementary. So we go 180 minus what? 90 minus this 90, and that gives you this 90. Make sense? All right. Now, if this is 90, then what's angle X? That's 90. So guess what we have now? We got a rectangle. We got a parallelogram with 4 right angles. That makes it a what? A rectangle. So what did I start with? I only started off with one right angle. Agreed? So just knowing that this parallelogram has just that one right angle, that automatically means that all the other ones are going to be right angles, and that means we have a rectangle. That's what this theorem is saying. We good? All right. That's pretty good stuff, right? All right, we learned what a parallelogram was. Now we're getting really down and dirty. We're really getting to know a little bit more about these parallelograms. And it doesn't stop at this lesson. We're going to do a little bit more. We're going to learn some more about parallelograms. All right, you probably thought, what a simple shape. How in the world is there so much to know about that little simple shape? But there is. There's a lot of stuff to know. All right, 2 more, and then we're going to do some examples. Let's go back to this regular parallelogram looking thing. Just make it look like this time. All right. This time we're going to talk about the sides. We're not going to talk about the angles. Just talk about the sides. Now, they tell you this is a parallelogram. Okay, so we do know it's a parallelogram. So that means we know this side and this side are parallel. This side and this side are parallel. They tell you that this is a parallelogram. All right. Here's what this theorem says. The theorem says that the opposite sides. So let's take a wild guess. Let's just take a gut instinct of this. The opposite sides of a parallelogram are, what do you think? It looks like they're equal, doesn't it? Like if I measured that and I measured that, doesn't that look like it would be about the same? Yeah, it does. Okay, what if I measured this one here and this one here? Yeah, it looks like they're equal. Does that mean all 4 are equal to each other? No. All right, but the opposite, what? Sides are equal, or you could say congruent. All right, so the opposite sides are congruent. So that's something that we know now. So what are they going to do on a quiz or a test? Not they, me. What am I going to do? What am I going to ask you on a quiz or a test? Well, I'll probably give you something. I'll probably say that that's 5 and that's 4. Then I ask to solve for X and I ask you to solve for Y. It probably won't be this easy, all right, but so what's X equal to? 5. What's Y equal to? Super easy, right? But you know I'm not just going to do that. That's too easy. What do you think I'm going to do? I'll probably put like X plus 5 and maybe make this thing, I don't know, 3X minus 1 or something like that, okay? So what would you do with these two? Let's actually do it. So X plus 5 equals 3X minus 1. And then just solve, right? Add a 1 to both sides, right? And then minus X from both sides. So that cancels. What's that? 6 equals what? 2X, right? That cancels. What's X equal to? 3. How do I find the length of that side? Just 3 plus 5. So what's the length of that side? That's 8. What's this one without doing any math at all? That's 8. You get it? Yeah, we just did that the other day with a whole bunch of homework problems, right? Yep. So that's the kind of stuff that I could ask you. But what's the geometry? The geometry is super easy. The geometry is just what? That the opposite sides are equal to each other. You got it? Okay, let's move on. Well, we've been doing the same kind of problems. Like, how often? We've been doing this since the beginning of the year, haven't we? Okay, well, we'll be doing a lot more of it, so that'll give you some more practice. All right, let's keep going. One more, and then we'll do some examples. So now watch this. Now let's see if you can be better than the other class. Shouldn't say better, but let's see if you know this better than the other class. All right? So if I connect this point to a non-consecutive vertex, not that one, but what? This one over here. What do we call that red line right there? That's what the other class said. Did I say anything about these two angles being equal to each other? No. If I go from one vertex, yes, you got it, diagonal, okay? And I begged the other class, look at your notes. People were flipping pages and everything, and they still couldn't see it. Well, we talked a lot about this, especially when we did that polygon thing, right? Remember we did like a six-sided figure. We did all those diagonals, figured out how many triangles we had. Remember that? Okay? So we use diagonals a lot. Agreed? All right. So that's a diagonal, that red line right there. I could put another. I'll tell you what. I'm going to use a different color, though. Let's go blue. I'm going to draw another diagonal from here, from this one to this one. So that's a diagonal. Whoops. All right, so here is what the theorem says. It says that the diagonals of a what? What's this thing? What's this white thing right here? Of a parallelogram, right? So the diagonals of a parallelogram. Now, this is something that you may not have guessed, but if you see it and then look at it, you're like, yeah, that kind of makes sense. I think it does. They bisect each other. We've used that word before as well. Let's see if you know what it means to bisect. So let's put some letters in here. Let's go A, B, C, D. All right. And let's call this one where they hit, call it E. All right. So what does it mean to bisect each other? It has that prefix. What's the prefix? It's bi, meaning what? Meaning what? No, bicycle. What's a bicycle have? It's got two wheels, right? Okay, so what does bisect mean? It intersects it. Okay, well, not at 2 points. It intersects at 1 point, but what does it do to that line? Like, it splits it into two, not just into two. No, two equal parts, okay? All right, so look at the red one. That blue one is splitting the red one into two equal line segments. Do you see that? All right, and bisect means they are equal. They don't just split them into two, right? I mean, I could take, I don't know. Here, let's just do this. We got 1, 2, 3. Let me put one on here. Okay, watch this. Everybody see this? If you're watching on YouTube, I just got these markers. I'm holding them up. There's 4 markers all end to end, okay? If I split this into two, that split it into two, didn't it? But did it bisect it? No. Okay, where would it bisect? In the middle, that's right. Into two what? Equal, not just parts, but equal parts. Equal parts. Okay, this, when I did this, that split it into 2 parts, but are they equal? No. All right, so there you go. All right, so what does that mean? That means that AE equals what? EC or CE, right? Everybody see that? What about this? What about BE? What does that equal? What is it? DE, right, or ED? Either way you say it, doesn't matter. You with me? Does that mean this little blue one right here, BE, is equal to AE? No, it doesn't. All right? But the blue one is split in half, all right? And the red one is split how? In half, or into two what? Equal parts, right? That's what it means by splitting it in half. Agree with that? All right. So that's what that theorem says. That's super important. So again, you know what I'm going to do on a quiz or test, don't you? I might give you this, right? What if I told you that AE was 3 and I asked you to find AC? No. Look, from here to here is 3. What is it from? Well, this 3, from A to E is 3. Okay? And then from E to C would also be what? 3. Then A to C would be what? 6. Everybody with me on that? All right. What if I told you that BD was 8 and I asked you to find BE? Right. So BD is the whole thing, right? And if the whole thing is 8, what is this part right here? That's got to be 4. And what's this part right here? That's got to be 4. You with me? Yeah. All right. Let's do an example. And the example is basically going to look just like this thing right here. But we'll redraw it because I already got a lot of mess in there. I'm going to make this a little bit bigger because the drawing, actually I'm going to flip it the other way. Let's see if I can just do that right here. I think I can. Flip horizontally. There we go. Look at that. And I'm going to make it just a bit bigger so we can write on it. Yeah, it's good right there. Let's move it up a little bit. All right. I'm going to put a couple diagonals in here. And so there's one diagonal. All right. And then here's another diagonal. Let's do it a different color. So we'll make this thing very colorful. All right. And they tell you a whole bunch of stuff. And I'm going to draw them in here. So let's go yellow with this. All right. So they tell you this left side, let's put the letters in here. So this is A, B, C, D, and we'll call this E right there. All right. So they tell you that AB is 6.3. So I'm not going to write these down. I'm just going to put them on the picture, okay? So they tell you that AB is 6.3. Where are you going to put that? Right there, okay? They also tell you that AE is 4.2. AE, where's AE? There's AE, it's 4.2, so I put it right there. You good? They also tell you BD. BD is the whole entire thing. So it's a whole red line. Very good. So that's 11.6. All right? Now they tell you some angles. Let's do a different color for the angles. What color should we do? Pink? Already did yellow up here. So they tell you ABC. Where's ABC? There's A, there's B, there's C. So what is ABC? It's that whole angle, and they tell you that that's 70, let's put it up here, 72 degrees. This is all the stuff they tell you, okay? It's all written down. You just have to put it on your picture. All right? They tell you that ACD. Where's ACD? There's A, there's C, there's D. That means it's this little one right here, and that is 63 degrees. I'll put two little arcs here so it's not the same as that, okay? And they tell you one more thing, ABD. ABD. What's that one? Let's put that in a different color. That's this little one right here. Do you see that? It's not the whole 72. It's just this little bit, and that's 41 degrees. In fact, you know what I'm going to do? I'm just going to slide that right in here. Okay? This is all the stuff that they tell you. Agreed? All right. So we just labeled it. Okay? We took our picture, we took our parallelogram, and we labeled everything with what they told us. All right? They listed it all down. I'm not going to do it. So now what they're going to ask you to do is they're going to ask you to find a whole bunch of stuff. So they're going to ask you to find DC. That's a segment, it's a line segment. They're going to ask for EC. And they're, okay, just let me write them all down first, then we'll take a look at it. This is the E. They're asking for ED. And then they ask for some angles. They ask for angle DAB. Some of these are super easy. some of them you got to think just a little bit. This is ADC they ask for, and then they ask for angle DAC. Somebody in the last class said, this is all one problem. You're going to put this as one problem on a test or a quiz? No. This would be, I'd probably make, if I did something like this, I'd probably make it 6 problems, all right? This would be 1, 2, 3, 4, 5, 6. Everybody good? All right. But it is one problem for the example, and it might possibly be one problem in the book. I don't have them all memorized. All right, let's do it. DC. Raheem, you already said it. DC is right here. So if this is 6.3, then opposite sides are equal, right? So without any math at all, that's going to be 6.3. All right? EC. EC is right there. All right, look. If this is 4.2 from A to E, what is it from E to C? It's the same exact thing. It's 4.2. Super easy. Didn't have to do any math, did we? Just had to look. That's all we did. 4.2. ED might be a little trickier. Not much, but a little bit. ED. Where's ED? You got it. From E to D is right here. Okay? What do we know? I know the whole entire red line is 11.6. How do I find this? Divide by 2. 11.6 divided by 2, and that's 5.8. Okay? No. That was the other thing. Okay? This is being bisected. It's split into what? 2 equal parts. So you don't divide by 3, you divide by 2, because this is half of the whole thing. All right, let's do the angles. You ready? Let's use pink on this one. DAB. Where's angle DAB? Well, there's D, there's A, there's B. So what am I looking for? I'm looking for that whole angle right there. So we got to think a little bit on this one. Is it 63? That whole thing? Is it 72? What do we do? Just tell me the math. Ooh, no. No. Just give me the math. What's one of the first things we talk? I think it's the first thing that we talk about today about parallelograms. What was true about the consecutive angles on a parallelogram? Look in your notes. Look in your notes. What's true? Listen. What's true about the consecutive angles on a parallelogram? They're supplementary. So that means what? Say it, Josh. It's 180 what? Good, you got it. So it's 180 minus 72, which is 108. So this pink angle right here is what? 108. All right, you got to think of the theorems that we talked about today, right? You got them in front of you. I'm sure you took great notes, right? Okay, and you're awake, except for a couple. Their heads down on their desk. Just don't understand why you would have your head down when we're doing this stuff. So this is 108 degrees. Okay, what about ADC? Let's find that. There's A. Where's D? Down here, and there's C. So it's this one right here. How'd you get that so easy? Nate? Because they're opposite. They're not consecutive, they're opposite. I guess you could do this. You could say it's a consecutive angle with 108. So you could go 180 minus 108. But it's so much easier. Why, Josh? Why is that so easy? Because they're what? No. They're what? Come on. What is this angle to this angle? They're equal to each other, okay? Because opposite angles are equal. Opposite angles are equal. It's a wonder anybody learns anything in here. I don't know. So that's 72 degrees. All right. Now this next one, it's a little bit harder. So watch. Everybody look. We got a couple minutes left. So I will say this. If there's anybody listening to this YouTube video from the first class, I thought we would get further than what we did today because I told the last class, watch the end of the video from this class because I know I'm going to get further. Well, I didn't, okay? We ended up at the same exact spot. So there's a couple things we got to do tomorrow. Well, not tomorrow, but you know what I mean. Monday. So DAC, where's DAC? DAC, it's this little one. Let's go different color here. Let's go orange. Everybody look. Look, this angle right here. This orange one right here. That's what I'm trying to find. Is it? It's not 63. Now look. Look at this. No. Why you keep wanting to divide by 2? I never said that this was an angle bisector. No? We are going to use this. This is a hint. We are going to use that. But I'm telling you, it's not 63. You got it. You got it. Okay? How do you know that? Because watch. If this is 63, now watch very carefully. Watch. I got parallel lines cut by this blue transversal. Look at 63 and look at this angle right here. I know there's a lot of mess in here, but look at this angle. 63 and 63, they're alternate interior angles. So if this is 63, what's this angle right here? That's also 63. How do I find this one, though? The whole thing's 108. If this is 63, then I go, you got it, 108 minus 63. And that's what, 45? Yeah. So that is 45 degrees. And there you go. Wasn't that bad, was it? I mean, if you just walked in the door and saw this and said, this is what we're going to do today, you're like, what? I'm not going to be able to do that. But we took it step by step. All right, well, watch the video again. All right, that's the thing. If you don't know how to do it, watch the video. I still want you to do some work. So it's the same thing that I put on the lesson plans. So it's section 6.2. It's page 260. It's 1 to 17. And it's 21 to 24. Now, there may be, listen to me, this might help you out. Listen, there may be some problems. I'm not sure. I don't have the book in front of me. So there may be some problems at the end, maybe the 21 to 24 that you can't do. But I'm almost positive you should be able to do all of those. Okay? So get as much of that done as you can. That's due on Monday.